Greetings, Algebra 2 students. Welcome to our first e-learning video. Before we jump into the math, I wanted to kind of go over just some introductory, how are we going to e-learn? I've gotten some emails from some of you. So here's what we're going to do first. We're all going to breathe. We're all going to breathe. We're going to get through this okay. I am not super worried about getting through this, so I don't want you to be super worried about getting through this. And here's why. This is how this e-learning is going to work. The first thing is, if you look in this post, I posted the notes that aren't filled in. If you have access to a printer, go ahead and print those out. So stop this video, print them out. If you don't have access to a printer, no worries. If you want to, this is what I'm doing here. If you do have an iPad, you can download the PDF into an application called Notability. I think the application Notability is like a $9 app, but it's worth the money. And I can walk you through that. Just email me if you don't know how to do that and are interested. I think that some touchscreen Chromebooks can do the same with an app called Kami, but I don't have a Chromebook to kind of help you with that. But friends, if you don't have anything, that's okay. I've given you so many papers, find a piece of scrap paper. And then as we go through an example, write the examples down with us, just like you were in class. Okay, so right now, you're on video 1, and I'm separating these today just into 2 videos, just because I'm doing all of this intro work, and I feel like people are more apt to watch 2 smaller videos than 1 bigger one. But here's what's important. I am not going to give you the wait time that I do in class. I'm just going to teach. I'm just going to go through it because I don't want to make the videos longer than they need to be. So that means you can stop, rewind, or pause me at any time. And believe it or not, some kids like the video because they can kind of work at their own pace, or you can do it at 8 o'clock at night if you'd like. I also have some of you that like to work ahead. So feel free to mute me. And then you can kind of do the work and see if we get the same answer. And some kids are just like, I get it and can fast forward me and learn it quicker. So hopefully this will appease to all learning styles. All right, again, for today's lesson, normally every time I give you a new e-learning post, you'll have a video to watch. I'm only breaking this down into videos 1 and 2 because video 1 is going to be more introduction and introduction to e-learning and introduction to the lesson. Video 2 is going to be like the concrete examples of how I do my homework. So that way you can go back to video 2 without having to listen to all of this and fast forward again. All right, so what are you going to do? You're going to print your notes. Download your notes, get scrap piece of paper. You're going to watch the video and you're going to write along with me. And once you've done all of that, then you can start your assignments. And your assignment, I'm only giving you one assignment, not several, not a worksheet A, not a worksheet B, one. One assignment that is due by Friday at 11:59. So how will you do that? Take a picture of it. And then you should be able to turn it in on Google Classroom. I think the easiest way to do it is to just take pictures and do it from your phone. As a reminder, I'm going to go slow with the curriculum. So that means that I might cut out a section here and there. But next week, for instance, next week, I'm not going to teach you anything new. I'm still going to give you a video every day, followed by an assignment. But next week, I'm just going to review everything we did before spring break and what I'm teaching you this week. But again, I'm still going to have another video that will help you through those homework problems. And I know some of you might be like, well, I don't want to learn from the video. Friends, we have distance learning. You're going to have to watch those videos and write stuff down. I don't have enough time to give everybody individualized lessons every day. That's why you only have 90 minutes worth of work that I am giving you. And like, for instance, the district has said I'm basically only needing to work a half a day because we still have families and things that we're dealing with at home. So we're going slow. We can do this. Some of it's going to have to be, you're going to have to learn from these videos. But you guys, I understand you're going to have questions. So 10:30 every day, we will meet on Google Meet. tomorrow, or you will see at 10:28, there will be a post on Google Classroom inviting you. All you have to do is click that link and join, and it should work out very well. If anything doesn't, feel free to email me at any time. Okay, friends, I know that was a lot of information. It's okay. Let's just do step one. Let's start the notes process. All right. And you guys, once we get through this first one, it will just be patient. I can't stress that enough. Patience. You guys, it's going to be okay. All right. Are you ready? We're going to do this. We're going to do it. Let's start. I'm only going to go through the first few slides, and then I will make a new video. All right, Unit 6, Lesson 2. We're going to solve radical equations, like totally. And here we go. What makes an equation a radical equation? Okay, let's think about where you've come from, friends. All right, when you were back in middle school, you solved equations like x plus 3 equals 7. This is linear. This is linear because it's an x to the first. In Algebra 1, and then this year a lot, we have spent a ton of time dealing with problems where we have an exponent of 2. Those are quadratics. Then we even talked about how to solve problems where the highest exponent was 3, so you got 3 answers, or the highest exponent was 4, and you got 4 answers. And we called those polynomial equations. So now we're adding to that repertoire of solving equations. So a radical equation is either an equation that has a radical symbol in it. So if I give you the square root of x plus 3 equals 7, this is now a radical equation. Or if I give you the cube root of x plus 3 equals 7, this is a radical equation. But this is not the only way to write radical equations. You can also use rational exponents, and that's what we did before spring break. In a radical equation, remember rational means fraction, and exponent means a power. So I can rewrite the square root of x plus 3 equals 7 by writing it as x plus 3 to the first power over 2, which is the root. I can write what I have written in pink as x plus 3 to the first over 3 equals 7. So friends, what I have written in orange and what I have written in pink are the exact same problem, exact same work. The difference is one has a radical symbol in it, and the other one has a fraction that is a power. This is what we're going to be solving in this lesson. The good news is I can give you a recipe. I can tell you how we are going to solve these every single time. So, step 1, we are going to isolate the radical on one side of the equation if necessary. You have done this in the past. When? Well, remember when I've given you problems like x squared plus 3 equals 12? And if we're going to solve by square roots, I told you that whatever is being squared has to be by itself on one side. So we subtracted 3 to get x squared is equal to 9. And now we can say that the x squared, now we can say that the x squared is isolated. So friends, you have isolated before. Now we're just going to do the same thing with the radical. If I have radical x plus 3 equals 12, we're going to have to get the radical by itself before I can do anything else. Step 2, you have to remember the following. This is a big concept. Again, bear with me. Patience, patience, patience. All right, powers and roots, they undo each other. They undo each other just like 3 plus a negative 3 cancels. Just like if I take 4 divided by 4 and they cancel. powers and roots undo each other. So for instance, let's take this example that I did earlier. If I have x squared equals 9, didn't we take the square root of both sides because the square root and the square undo each other? So that idea is step 2. We're going to raise each side of the equation to the same power to eliminate the radical because powers and radicals undo each other. Step 3, we're going to solve the polynomial equation using the techniques you've learned in previous chapters. And it's step 3 where kids have issues, believe it or not. What happens is if we result in a linear equation, kids are cool. If we result in a quadratic or a polynomial, that's where the breakdown becomes. So you do have some prerequisite knowledge that's going to kick in. Last but not least, and I cannot stress this, this is a must. Friends, you are going to have to check your answer. Why? Because you can get what are called extraneous solutions. The word extra is in that word. You can do all of your math completely correct, and you just end up with answers that don't work. Friends, that does not happen in the other types of equations we've learned. You don't have to worry about extras when we do linears, quadratics, or polynomials. You don't have to, but you do have to worry about them when we learn how to solve this new kind of equation. I'm going to do example 1. It is simple, and that will conclude this first video. And then the second video is going to be just to the point. We're going to do the examples. Okay, example 1. Step 1 is we need to isolate the radical. It is the square root of x plus 6 is all by itself on the left. All right, step 2. We need to power it up. So notice how this is a square root or a radical problem with a square root in it. By the way, I might say some dumb things. I'll correct it. Again, patience on the video. Thank you. All right. So since this is a square root, square roots are undone by powers of 2. So here's what I'm going to do next. I am going to raise each side to the power of 2. That is what this step is saying. Let's do that. Okay, as a reminder, the power of 2 and the square root, they undo each other, leaving me with x plus 6. 3 to the second power is 9. All right, let's look at step 3. On step 3, it says to solve. Friends, this is a linear equation. You love the ones that result in a linear equation. They're easy, they're straightforward, they check great. So I'm going to subtract 6 from both sides. Final answer is x is equal to 3. But now we need to check our answer. All right, so how do we check our answer? And let's get off the highlighter. All right, you're going to take your answer and plug it back into the original problem. Okay, so let me erase all of this. X, the square root of x plus 3 is the original problem, so I substituted in the 3 for that x. All right, so if you need to, you can use a calculator. All right, I can do the square root of 3 plus 6, and my result is 3. Does 3, and I know that's not the same calculator as the one that you have, but that's the one that I have available on my iPad. All right, so does 3 equal 3? Yes, that checks, and all is good. Breathe. We got through that first example. Did you think that was okay? I think you did. So you guys, we can get through this. I will look forward to seeing you on video 2.